Hello all, my name is Alejandro Sainz. I'm a staff application security engineer at Twilio. First, a little bit about myself. I was born in the DMV and I'm still here. I have three amazing kids, a ninja nurse wife, and a dog named Master Chief. Throughout my career, I've bounced between development and security, and currently I am a staff application security engineer at Twilio, where I mainly focus on security tooling and automation. I joined the team in 2021. The agenda today is going to be pretty straightforward. We are going to discuss our internal security metrics framework, Multivac. We will go over how to build your own Multivac, how to correlate multiple metrics, and finally, the challenges we faced with having our own security metrics framework. Security metrics are a way to measure and assess our security tools, processes, and practices. But my definition is influencing decisions and processes by creating stories consisting of data. Long story short, metrics drive impact. They give us oversight into our tooling effectiveness and whether we are getting a return on our investment. It enables us to enhance vulnerability management by measuring findings and features from our security tools. It allows us to correlate security metrics from different security tools to have a bigger window into our risk profile. It gives us preliminary information for zero-day responses. And lastly, it gives stakeholders greater visibility into our security tools and vulnerability management processes via dashboards. So, how did we do it? We built a security metrics framework called Multivac, name inspired by Isaac Asimov's short story, The Last Question. But what was the motivation behind building Multivac? We needed a security metrics framework that could easily be scaled to have multiple security metrics jobs. At the time, our security metrics jobs were deployed in different environments. We wanted to consolidate them into a single monorepo. We wanted to empower engineers to introduce their own security metrics with a less difficult learning curve. Infrastructure as code was used to eliminate manual configurations of cloud resources. And we wanted the engineers to only be focused on crafting security metrics and not to worry about backend development. Most importantly, our team could build faster than buying a solution. So how did we really build it at a very high level? We deployed it via infrastructure as code. We utilized a mixture of AWS Lambda and scheduled ECS tasks, depending on the runtime. These jobs were triggered by AWS Event Bridge, and these metric sources would connect to our security tooling APIs, where we then refined and enriched our data and converted them into security metrics. These metrics were then pushed to our segment CDP, which was then pushed downstream to our data lake, where it was connected to our dashboard visualization tool. But first, a quick preface. This is how we designed and built it. We leveraged the tools that were readily available to save time. And everybody's toolbox is different. So ask yourself whether building has more value than buying. All right, let's build your own Multivac. Multivac was born because my manager asked me to build a security metrics framework before paternity leave. This exposed a bunch of problems. My team uses many security tools that were at the time deployed sporadically across the company. Each tool had different directly responsible individuals, and we didn't know who the stakeholders were and what they cared about. It was difficult to understand how these tools were performing or what their coverage was. Coverage meaning, what are these tools looking at, and are they looking at everything we have, especially our most important assets? These unknowns, and because my daughter was on the way, left me feeling a bit anxious. However, with any big challenge, I always tend to ask questions and write it down. What tools or processes can we leverage to save time and save design and development time. I didn't have the bandwidth to build metrics for all our security tools. So how can I leverage my team so they're empowered to build their own while I'm away? Every system needs to be maintained. So what documentation do I need to make my teammates successful? All right, let's go over the security metrics framework recipe. If your team utilizes multiple tools, I recommend tackling them one at a time. Learn with one and iterate through the others. If you have any, talk to your stakeholders. Ask what keeps them up at night and how your security tools can help them sleep better. Based on that feedback, build out requirements. Not all security tools are equal. The existence and qualities of the APIs are inconsistent and require different implementations. Therefore, do a deep dive into the documentation and understand their limitations. Additionally, we want to make sure that security tools are able to scale with load you're requiring from them. If you can, partner with your tooling vendor on this endeavor. As always, we want to follow security best practices, so discuss with your team how you will securely store the tooling API tokens. First, we need to understand who the stakeholders are. Are they your team? Are they your department, business unit, engineering? Most likely, multiple stakeholders will require different things from you. Make sure to define it and write it down. Stakeholders can help you determine who ultimately is going to be accountable for quality security metrics. They will also help you find who will be owning the outcomes of these metrics themselves, such as specific vulnerabilities. And most importantly, stakeholders are your sponsors. They will back you through the project to ensure security metrics align with business goals. For example, a business goal could be to reduce the number of P1 SCA tickets being created. So based on this, we can define an OKR or whatever framework you use to reduce the average number of P1 tickets by introducing sneak pull request checks. We will measure the P1 tickets created and the P1 tickets possibly blocked by the sneak PR check. That delta is what we will measure for success. A metric source is a service that will fetch data from the security tooling API and convert it to security metrics. But with this, we will need proper development environment and understanding whether we are building the services ourselves or with a low-code solution. If we are building, make sure to use a programming language that is accessible to your team. If your team mainly writes Python, use Python. As mentioned in the previous slide, all APIs behave differently and may require specific implementations for pulling large sets of data. Some APIs will require pagination or have specific rate limits that need to be adhered to. Some APIs, such as GitHub, have a limit on how many times per hour you can request. Keep an eye out because some security tools have SDKs or libraries available to automatically handle these situations. Logging and monitoring. Our metrics need to run when they're required to run. If they don't, the team needs to be alerted and fix the problem. Not doing so will result in data loss for that time. Lastly, we want to establish a cadence or when your metric sources should be triggered to run. This could be a cron or maybe collected with events such as with webhooks. In your services, we need a way to refine and enrich data into security metrics and have a place we can store them. During this process, we will have to define a standard schema or essentially what a security metric object or type will look like for consistency. We have to ask ourselves, are we collecting only what we need or should we collect all the things? Align with your stakeholders. After this decision, we can convert the data into actionable security metrics. For example, if we were collecting metrics on P1 SCA vulnerabilities, maybe we want to collect properties such as severity, exploit maturity, reachability, etc. Next, make sure to timestamp your metrics. This will allow you to have a snapshot of the day those metrics were collected and allow you to build overtime graphs to measure performance. As for how to store your metrics, choose something that you are comfortable working with, but make sure it fits your performance needs. Work with your stakeholders to determine how long we should store the metrics. And similarly to metric sources, Ensure you have proper login and monitoring in place to prevent data loss. The last ingredient needed is how to present your security metrics. Choose a data visualization tool that integrates with your data store. Make sure it has the features such as the ability to create custom dashboards and ways to further enrich your security metrics. Ultimately, the dashboards created will be available to your stakeholders, removing the need for them to require access to the various tools you or your team may have. Cool. So let's bake all of these ingredients together in a theoretical framework. A bit anticlimactic, but this is how a security metrics framework could look like in the design phase. In this example, we have each of the ingredients mentioned before, starting with security tools at the bottom, represented by their 3 APIs and 1 webhook. Next, we have our metric sources that expose 3 metric cron jobs and 1 API endpoint, which will receive the data from the webhook. Additionally, this is going to be built with Node.js and will have a computation layer to convert the API data into security metrics. The security metrics are then going to be inserted into a Postgres data store where each table represents a metric source and their corresponding metrics. Lastly, the Postgres data store is connected to Grafana, where the security metrics are displayed via dashboards. For this design, I specifically chose to use free, readily available open source software. But there are many ways it can be built, and it could look nothing like this design. Now that we have theoretically built a security metrics framework, we can theoretically correlate metrics from different sources. We can use common contextual identifiers from different tools and build relations between them. In this example, we are collecting metrics from our SCA, secret, SAST, container security tooling, and our organizational taxonomy system, or who owns what. This allows to build team scorecards so that teams can measure their security hygiene and stakeholders can measure the security hygiene of all teams. Obviously, with all software, there are numerous challenges that need to be addressed. We ran into issues that were beyond our control, such as API migrations and stakeholder requirement changes. Robust error handling is a journey. At the early stages of Multivac, we were alerted on so many issues that we had to address individually. Over time, our alert channels pinged us less and less. We also ran into a lot of rate limiting issues, which falls in line with the next point of maintaining software. Update your dependencies, write quality documentations, and write unit tests. Building your own framework requires consistent monitoring. Ensure your team is trained to fix incoming issues. And lastly, long-term support. This is software that you or your team owns that others rely on. Treat it as an asset. Last but not least, always consider the build versus buy question. As mentioned before, my team is motivated to build and maintain our internal tools, and we had the time and budget to do so. Ask yourself if you have time to maintain software in addition to your operational work. Sometimes buying a solution, such as an ASPM, is ultimately a better choice. And with that, if you have any questions or comments, you can reach out to me on LinkedIn. Thank you.